Hello students, today I am going to talk about Kirchhoff's law, that is a topic from the 12th physics, chapter name is current electricity. So Kirchhoff's laws are a very important topic to analyze a very complex circuits of a physics, or you can say electrical circuits. And in this I will start with the first Kirchhoff's law. According to that, the statement is the algebraic sum of the currents into any junction is equal to 0. Okay, so look at an example where there are 5 currents, out of which there are 2 currents towards the junction. What is junction? Basically, junction is this point O. So according to this rule, the sum of the currents will be equal to 0. So we will take the currents I1 and I2 as a positive because that are towards the junctions, means they are entering the junction. And I3, I4 will be taken as a negative because that are leaving the junction. Okay, so the sum will be remain equal to 0 according to this definition. So when I rearrange it, then I will get here I1 plus I2 is equal to I3 plus I4 and plus I5. Okay, so according to the statement of the Kirchhoff rule, we get the sum of the currents entering the junction is equal to the sum of the current leaving the junction. Okay, and this is a very important rule. If I talk about the one example that is related to this rule, we want to calculate the value of I. Here 3 currents are towards the junction, okay, and the 2 currents are away from the junction. So we will use this law, that is the junction law. According to that, the sum of the currents entering here, that are I plus 4 plus 2 will be equal to the 5 and plus 3. Okay, so from here you will get here 5I plus 6 is equal to 8, and the value of I will be you can say 2 ampere. Okay, so we can easily calculate the values of I in a given electrical circuits. Okay, next is Kirchhoff's second law, that is the algebraic sum of the potential difference in any loop, including those associated with the EMF and those of the resistive elements, must be equal to 0. Means the sum of the potential difference should be equal to a 0. And the important thing is here is there are 2 types of the loop, because it is a loop rule, and we will consider two loops here. That is one is the clockwise direction and another one is in the anti-clockwise direction. So in our circuit, I will explain all the circuit on the basis of this clockwise loop. Okay. So, but there are a few rules which you all keep in mind. If, for example, if any cell is given like this, okay, here it is the positive terminal of cell and it is the negative, and the EMF corresponding to this is E. Yeah, as I mentioned here, I will consider only the clockwise loop in our circuits. So that is toward this. Okay. So rule is that if we are going from positive to negative terminal, we will consider its EMF as a minus E in a given circuit. Okay, and opposite to this, if it is given like this, here is a negative terminal, yeah, and here is a positive terminal, and our loop is again clockwise, then it will be taken as a plus E in a circuit. Okay, similarly corresponding to the as mentioned here, resistive elements. Corresponding to the resistive elements like this, having resistance R, say current is toward this side, yeah, and the R loop is again clockwise, then it will be taken as if I write it as plus here and minus here, because current is flowing from higher potential to lower potential. Okay, then it will be taken as, again it is going from the positive to negative, so it will be taken as minus IR in a circuit. Okay, and if it is given like this, okay, current is toward this side, and it is a resistance R, again loop is clockwise, it is going from positive to negative, means higher to lower potential, then obviously it will be taken as a plus IR in a given circuit. So these are very important rules mentioned in your copies notes. Keep all the rules in your mind and let us solve this problem. Okay, here there are 2 loops, both are clockwise. So this is first loop and this is second loop. And this current I1 is flowing through this resistance R1. So we can write here I1, and this I2 current is flowing through this resistance R2. So we can write here as I2. So both are clockwise loops. So let make an equation corresponding to this loop. As this loop is in the direction of this current, so according to that rules, as I mentioned before, we will take in here minus I1 R1. Okay, and again this loop is along this current I2. So it will also taken as minus I2 R2, and corresponding to this cell, it is going from negative to positive terminal. So that's why it will be taken as a plus E1 in a circuit. So it is equal to 0. So this is our first equation corresponding to this, you can say loop 1. Okay. Now next is corresponding to loop 2. You will get here say this current I3 is flowing through this resistance R3, and you can write here as I3. Okay. So corresponding to this loop 2, you will get here as this loop is opposite in the direction corresponding to current I2. So it will be taken as plus I2 R2. Okay, and here it is in the direction of current, so it will be taken as minus I3 R3, and again it is going from positive to negative terminal, so it will be taken as minus E2. So we will get two equations and we can solve both, and correspondingly we can study this circuit. Okay, one more thing you should keep in mind, that if we want to calculate the potential difference between the 2 points as I mentioned here between A and B. So for that, how we will apply this Kirchhoff's rules? So as we discussed before, in a closed circuit, we are applying a clockwise loop. So according to that, the circuit, if we analyze it, then corresponding the equation will be minus E and plus IR is equal to 0 when this is a closed. Yeah, if it is open from this side, as I mentioned here, this is a A terminal and here is a B terminal, and we want to calculate the potential difference across A and B. Say here is a point BA minus BB. Okay, we want to calculate this potential difference. So for that, we will start from this point A. So we will write here VA, and as we mentioned here, yeah, according to this loop rule, we will start or you can say make here the loop in this direction, that consider in a clockwise direction. So we start from this A, and we mention here minus E and plus IR according to the previous rules as we discussed the last example. It is equal to a BB. Okay, if both are attached here, yeah, as mentioned here, then this BB is equal to BA, and that will be cancelled and comes equal to the 0 as that is given here. Okay, so the potential difference corresponding to this, you can say circuit, that will be VA minus BB. I rearrange it, this equation correspondingly I will get here E minus IR. Okay, let us find the potential difference between the point A and B as in given figure. So to calculate that, as mentioned here, the potential drop is 2 volt across the same series arrangement of the 15 ohm. Yeah, and this is the 15 ohm and this is the 50 ohm. So if I write here, the equivalent circuit will be here is 15 ohm and this is a 15 ohm. Both are parallel to each other, and here is a 2 volt power supply, that is a cell here. So 1 by R equivalent will be 1 by 15 plus 1 by 15, so that is 2 by 15, and you will get here R equivalent is 15 by 2 ohm. Okay, and this send a total current toward these two series arrangement. So you will get here V is equal to IR, that is 2 volt cell is equal to I into R is 5 by 2. So I will be 4 by 15. If I apply Kirchhoff's rule here, and this current is I and this arrangement of the series resistors are same, so current will be here is equally distributed, that is I by 2 and I by 2. So as we want to calculate the potential difference across A and B, yeah, so for that I will use same rule, that is VA. 2 resistors only between A and B, so it will be, and in the direction of current we are considering the loop, and so we will take it as a minus 10 into I by 2 is equal to BB. So this will be 5I, and so VA minus BB is equal to 5I, and put the value of I in terms of V, that will be VA minus BB is equal to 5 into, what is I here? That is 4 by 15. So you will get here, so this is 4 by 3 volt. So your answer is the potential difference between the terminals A and B is 4 by 3 volt. And this is the final answer. I hope you all learn a lot from this 10 minutes, approximately 10 to 12 minute lecture. And thank you so much for joining.